right now, energy radiating from the sun is making me sweat. Fortunately, solar power technology also allows me to use the sun's energy to cool off a bit. Your move, sun. Right. Anyway. Solar panels were first used to power satellites back in the 1950s, and since then they've become much more efficient and widely used. A panel like this one converts light into electricity using an array of photovoltaic cells. These cells are surprisingly simple devices, similar to diodes.
A diode uses two types of silicon stacked together to allow electrons to pass in a single direction. Negative, or N-type silicon, which has an excess of electrons, and positive, P-type silicon, which has an excess of electron holes. Similarly, a photovoltaic cell uses a wide, flat layer of P-type silicon covered by a thin layer of N-type silicon. A single large flat metal conductor is connected to the bottom of the cell, and thin metal finger-like conductors are placed on top, which leaves most of the cell's surface exposed to light. When light hits the surface of the cell, photons pass through the top layer and hit the junction between the positive and negative layers. This knocks electrons out of their holes and towards the top of the cell, while those resulting holes are pushed down towards the bottom. When we connect a circuit to the cell's conductors, electrons leave the negative layer and travel through the circuit in order to reach the available holes down on the positive layer. All the while, more photons are knocking electrons out of holes, and the cycle continues.
That's quite a bit different from what a diode does, eh? I mean, a diode can't generate electricity or respond to light. Or can it? Okay, here we have a bunch of silicon diodes. They're the small signal type, so they have glass packages which should allow light to pass directly to the silicon. By wiring them all up in parallel and exposing them to light, we can see that, in fact, they do produce a little over 200 millivolts. And what about light-emitting diodes? A row of 8 red LEDs produces about 1.4 volts. These little tests won't produce much current, but they prove that diodes and LEDs do work in similar ways. But I digress. A single photovoltaic cell can provide half a volt. This panel here has 2, 4, 6, 8, 10, 12 cells, so it can provide 6 volts. But depending on lighting conditions, that output power can change quite a bit. So the best way to use it is as a means to charge a battery, and then use that battery to power whatever it is you need to power. In order to charge my 3.7 volt LiPo battery here, I'll take the output from my panel and feed it into a specialized charging circuit. This circuit will manage the unstable output from the panel and provide a steady charge to the battery. This small power boost circuit will convert the 3.7 volts from the battery to a standard 5 volts, suitable for use in USB devices, microcontrollers, and what have you. In any case, even after understanding how it works, having the ability to convert light into electricity is still pretty mind-blowing to me. So go make something solar. But don't wear a black suit on the roof, because it's hot. Can I get a towel from somebody here?